Comparing Functions by Natalie Davidson. Exponential scenario. My scenario is based upon human population growth. In 2011, the human population was 6.9 billion. In 2018, the human population was 7.5 billion. In 2025, the human population is estimated to reach the 8 billion mark. Let X represent number of years and let Y represent number of people. Here we have our X and Y column. X is going to represent input, Y is going to represent output. We have a 7-year difference, so it goes from 1 to 7 to 14 in our X column, and the Y column is going to be a bit different. It goes from 6.9 billion to 7.5 billion to 8 billion. The difference between 6.9 billion and 7.5 billion is 600 million, and the difference between 7.5 billion and 8 billion is 500 million. And it's not at a constant rate of change, which means that our function would be exponential. Over here, we have a visual representation of an exponential function. This is not to represent the word problem. As you see, the line is curved and not straight. Linear scenario. My linear scenario is based upon wages. I work 8 hours a day. I get paid $5 an hour, 4 days a week for the first week. Then I work 5 days for $5 an hour the second week. The third week, I work 6 days a week for $5 an hour. Let the amount I get paid represent X and the number of days I work represent Y. Again, here is our X and Y column. X represents input, Y represents output. We have our first week, second week, and third week for our X column. Our Y column is how much we earned in that week. $128, $160, and $192. The difference between these three columns is $32, which means it's going to be at a constant rate of change. That makes our function a linear function. Over here is another representation of the visual effect. It's not to represent the word problem, but as you see, a linear function would be a straight line on the graph. Comparing scenarios. Here we have our linear, and here we have our exponential. Linear functions model at a constant rate of change, while exponential functions model at a rate of increase or decrease. The function on a graph would be a straight line. The exponential function on a graph would be curved. The linear function has a constant slope, y equals mx plus b, and the exponential function does not have a constant slope. The end.